This is a video tutorial for working with hillshade and digital elevation model in ArcGIS. And there's 3 essential steps to accomplishing this task. The first one, we would just want to review a working directory and make sure we have it set up correctly. We want to understand the z-factor when we're working with DEM, especially in WGS 84, which is oftentimes the case. We want to run the hillshade tool within ArcGIS and make sure that the parameters of the tool are correct, and then view the surface that we actually achieve. We're going to use what's called the z-factor, and here are the values for a z-factor or a z-factor chart, which I'll review in just a moment. Let's go ahead and take a look at the working directory to get set up. So the first thing we want to do is make sure that we have a folder that we can use that's going to be set up correctly. So here's one that's on the desktop, and it's just called C4 assignment or a class 4 assignment. And we want to make sure that we have a input roster. So in this case, this was downloaded from Open Topography, and it's the SRTM 30 meter product, and you can see it right here. So it's in TIFF format, so we have that. And I've also set up a surface exports folder. So we're just going to export a series of surfaces in this series, and the first one being hillshade. So as long as we have a folder set up and we have a directory ready to go, we can go ahead and start. So I'm going to go back into ArcMap here. In ArcMap, I'm untitled currently, so what I'm going to do is make a connection to the working directory. Go into class 4 and make that connection, and here we go. So we have an input roster, surface exports. That's great. So the first thing I'm going to do is just go ahead and import the roster. So this will be digital elevation, and this particular location is in Pakistan, close to a city called Islamabad, and you can see just from the DEM itself, the low values are in the 500s here. Down in the plain area, and then as we go into high elevation, sort of at the foothills of the Himalayas, we have a dramatic increase in elevation. So we should be able to produce a hillshade that's relatively dramatic because we see a lot of elevation change in the original roster. So the first thing we want to do here is, let's take a look at our directions. We want to understand what a z-factor is. So let's go take a look at the z-factor in ArcGIS. So currently, if we take a look at our units, they're in decimal degrees. So if we look at the product, let's go down to properties and review the product. Under source here, we can see that cell size is in decimal degrees. And we can continue down a little bit here, and we can see indeed we have an angular unit of degree. So whenever this is the case, which is oftentimes when you're downloading digital elevation models from the web, specifically from a site like Open Topography, where you're using a product that's at 30 meters or 90 meters, it's going to be in this format. And the issue here is that the XY measurements are in decimal degrees. Right, so it's an angular unit. However, the actual units that are being shown in the product, that's what are called the Z values. Okay, so those are at every cell there's going to be a value, and that value is representing elevation. That elevation is measured in meters. So there's a disconnect between the actual XY measurements, or what we might call the planar measurements, and the actual elevation measurements. So we have to correct for that difference. If we were using something that was projected, our XY measurement would be in feet or meters, and it wouldn't be such an issue. But when we actually have different measurement types, then we need to correct based on a factor. And the factor changes based on latitude. So based on the chart, we can see that each latitude is going to be slightly different. And when we're picking out a factor to use, the factor is relative to simply 10, 20, 30, 40, 50, 60, 70, 80 degrees of latitude, and that's plus and minus. So you just need to pick one that's close to your location. So in this case, if I just take a look at the product, I'm going to be in between 34 and 33 latitude. So I'll pick the tranche that's at 30. So let's go back to our chart, and you'll have access to a chart. If I go back to the chart itself, I can see that my 30 for Z factor is 0.00001036. So that's the one I want to use. And you really need this chart to correct for the Z factor because you're not going to remember these numbers. Just remember that whenever you're utilizing DEM in desktop software and you need to run a hillshade or run slope, you need to do this process, this little extra add-on. And then of course, if you are already in a projected product, this is not going to be an issue. Okay, so I'm just going to go ahead and copy this value, and I'll bring that into my tool. So let's go ahead, and the next step is we want to actually run the tool on the product. So I'm just going to go to Arc Toolbox here, and we can take a look at the path. The path is Arc Toolbox, Spatial Analyst Tools. We go to Surface, and then Hillshade is the tool we want to work in. Toolbox over here, and Spatial Analyst Tools, and then I want to go down into Surface, and under Surface we can see all our surface tools, and towards the middle we'll see Hillshade. So let's click on Hillshade. So we're going to input our DEM. Once that's done, we're going to export the product, the resulting product, out to our surface export folder. So let's set that up. Okay, so in my folder I have something called surface exports already set up, and we'll just call this hillshade. And you might want to underscore your location. Okay, so it's going to go to a hillshade. I'm going to keep the azimuth and the altitude the default. And basically what the azimuth and the altitude represent is the positioning of the sun relative to the actual hillshade raster. So think of a hillshade as being shadows upon terrain, and how extreme we want that shadow to be is dependent on altitude and azimuth. So we can just kind of accept the default. That's usually the case. And you can see that we're getting an error here, or not an error, but a warning in terms of the Z factor. And that's because it sees the units as being different between the XY measurements and the Z measurement. So we're just going to go ahead and paste in our correction factor, which is this one for this particular latitude, which is between 34 and 33, and run it and say OK and see what we get back. Okay, so your resulting hillshade should feel quote natural. It shouldn't be too dark or too light. This looks like it's resulted in a really nice hillshade here. So we can see the actual elevation changes, we can see the actual shape of the terrain, and we have a shading effect based on the azimuth and the altitude that we accepted as defaults. And if we simply just click on, click off here, we can see that there's a direct correlation between the hillshade and the extreme changes in elevation. So whenever we see a dramatic difference between the dark and the lights, that's where we're going to get a sharp increase in elevation terrain, and that will be reflected in the hillshade. Now, a hillshade product is not necessarily an analysis product. We're not going to use the values that are being produced by the hillshade for any particular purpose beyond aesthetic product. Hillshades are excellent as a terrain base layer when you're producing cartographic products. So this allows us to overlay other rasters and also vector data and contextualize that overlaid data relative to terrain. And this is a very effective process, and we'll utilize it in this week's assignments as we overlay different products that are derived from digital elevation. So we want to start with hillshade, which we've just accomplished, make sure that we save hillshade, and move on to the next steps. So I'm just going to go ahead and save this as an MXD in the folder. So I'll go into my folder here and I'll just call it hillshade. And I can start on my next products off of the hillshade MXD that I produce. So just go ahead and save that. And that brings us to the conclusion of hillshade, and now we'll move on to some of the other products.